6.5 Dynamic NAT 6.5.1 Dynamic NAT Scenario Dynamic NAT automatically assigns a public IPv4 address to an inside device from a pool of available public addresses. The key difference is the static NAT has one private IP for one permanently assigned public IP, and for dynamic NAT is one private IP for an available public IP selected from a pool. The mapping is temporary and create when needed. When the translation is no longer needed and expires, the public address can be returned to the pool for another device. This figure illustrates dynamic NAT between inside private hosts and the internet. What is happening? PC1 and PC2 use private IP addresses on the inside network. When either PC needs internet access, the PC sends traffic towards the internet. The NAT router receives the traffic, and then the router chooses an available public IP address from its NAT pool. For example, PC1 with IP 192.168.10.10, and then send the traffic to the NAT router that selects an available public IP, and it picks 209.165.200.226, and then it goes to internet. If PC2 connects at the same time, it needs another available public address. So the PC2 with 192.168.10.11 gets 209.165.200.227, and then surf internet. Dynamic NAT use a pool of public IPv4 addresses called the Inside Global Address Pool. Public addresses are assigned first come, first serve. Each inside device gets one public address. This figure shows PC1 and PC2 on the inside network, accessing an outside server through Dynamic NAT. The process is PC contact NAT router, and then send the traffic to internet, and then at the end, the traffic goes to a server. When an inside PC sends traffic to the internet, the NAT router receives the packet with the PC private address, selects an available public address from the NAT pool, replace the private source address with that public inside global address, and send the packets towards the internet. When the reply returns, the router translates the public address back to the original private address and forwards it to the correct PC. The IP NAT pool command creates a pool of public IPv4 addresses that Dynamic NAT can assign to inside devices. The syntax is, first, make sure in the global configuration mode of that router, you enter IP NAT pool, followed by the pool name, the start IP and the end IP, the net mask, and the subnet mask. For example, in router 1's global configuration mode, you type IP NAT pool, and then let's call it NAT pool 1. The start IP is 209.165.200.226, and the end IP is 209.165.200.240. And let's assign the subnet mask. So use the net mask followed by 255.255.255.224. So let's break this to parts, and then let's discuss each part of it. The first one is NAT pool 1. That's the name of the NAT pool. And then the 209.165.200.226 is the first public IP available. And then the 209.165.200.240 is the last public IP available. That 255.255.224 is the subnet mask for these addresses. So this is the basic idea, that inside private IP, and then goes to select an available IP from the NAT pool 1. Once that address is picked, and then connect to internet. The router assigns the addresses from this pool dynamically on a first-come, first-served basis. Step 2. Configure a standard ACL to identify only those addresses that are to be translated. An ACL that is too permissive can lead to unpredictable results. Remember, there is an implicit deny all statement at the end of each ACL. In this scenario, let's define which addresses are eligible to be translated. So you enter access list 1 permit 192.168.0.0 and 0.0.255.255. Here are all hosts in the 192.168.0.0/24 network are eligible for NAT translation. Step 3. Bind the ACL to the pool using following command. So in the router config mode, you enter IP NAT inside source list. And then you have following options. They are the access list number or access list name. After that, you enter pool followed by the pool name. The example is IP NAT inside source list 1, pool, and NAT pool 1. Step 4. Identify which interfaces are inside in relation to NAT. This will be any interface that connects to the inside network. In the scenario, we identify interface serial 010 as the inside NAT interface. So first, you log into the interface configuration mode by using command interface serial 010, and you enter IP NAT inside. Step 5. Identify which interfaces are outside. In relation to NAT, these will be any interfaces that connect to the outside network. In the scenario, we identify the interface serial 011 as the outside NAT interface. So we use command interface serial 011 and then put command IP NAT outside. This figure shows two inside networks sending traffic to the internet. They are PC1 with IP 192.168.10.10 and PC2 with IP 192.168.11.10. When their packets reach the NAT router, Dynamic NAT replaces each private source address with an available public address from the NAT pool. So before NAT, PC1 source address is that 192.168.10.10, and after NAT, that source address is 209.165.201.5. Before NAT, PC2's source address is 192.168.11.10, and after NAT, source address is 209.165.200.227. The table reflects these translations. This figure shows the return traffic from the internet back to PC1 and PC2. The DA means destination address. When the server sends a reply, it sends the packets to the public address that it saw earlier. So the packets is from internet to 209.165.200.229 also to 209.165.200.227. When the packet reached the NAT router, the router checked its NAT translation table and changed the destination addresses. So that 209.165.200.226 changed to 192.168.10.10, and this is for PC1. Also, that 209.165.200.227 changed to 192.168.11.10. This is for PC2. We can use the show IP NAT translation command to display all the static translation. As you can see here, after entering this command, we can see the inside global addresses, also the inside local addresses. We can also add a verbose keyword to display additional information about each translation. As you can see in the example, we use show IP NAT translation verbose. And in addition to those inside local and inside global addresses, we can see the created time. We can see the time is created and then is being used, the time out, and so on. By default, translation entries time out after 24 hours, unless the timer has been reconfigured with the command IP NAT translation and then the timeout seconds. To clear dynamic entries before the timeout has expired, use the clear IP NAT translation privilege exec mode command as shown here. So in R2, enter clear IP NAT translation asterisk, and then you can use the show IP NAT translation to confirm. This table lists the command we can use for clearing the IP NAT translation, such as the first one is clear IP NAT translation with asterisk that clear all dynamic address translation entries from the NAT translation table. We can use the clear IP NAT translation inside and with those options such as global IP, local IP. This clears a simple dynamic translation entry containing an inside translation, or both inside and outside translation. We can also use clear IP NAT translation protocol inside with those options, such as global IP, global port, local IP, local port, and so on. This clears an extended dynamic translation entry. We can also use another command called the show IP NAT statistics to display information about the total number of active translations. As you can see in this example, after entering this command, you will see information such as the total active translations. Over here is 4, with 0 static, 4 dynamic, and 0 extended. The package translations, 4, and then we have the hits, 47, and the misses, 0. Besides those, we have the NAT pool 1 with the net mask 255.255.255.224, and then the configuration we entered in previous steps. Besides that, you can also use show running config command and look for a NAT, ACL, interface, or pool commands with the required value. So in this example, you enter show running config with pipe and include NAT. The result shows the information we expected, such as the IP NAT pool 1, and so on. Those are the information we entered.